Hi friends, today let's discuss about the hybridization in ethene. Ethene is an alkene and having carbon-carbon double bond in which each carbon is attached with two hydrogen atoms. So using hybridization, I'm going to discuss about how a sigma and pi bonds are formed between carbon and carbon and how sigma bonds are formed between carbon and hydrogen. So let's start with the hybridization by writing electronic configuration of carbon. Carbon in the ground state electronic configuration is 2s2, 2p2. So the orbital diagram will be showing like this, 2s2, 2p2. Now carbon in the excited state, the configuration becomes 2s1 and 2p3. Why? Because one electron from 2s is moving into 2p. So it changes to 2s1, 2p3, and this is how the orbital diagram. And in ethene, the hybridization is sp2, not sp3, it is sp2. It is one s orbital overlap with 2p orbital, leading into sp2 hybridization gives 3 hybridized orbital. It means the last p orbital is not participating in hybridization, so that the last p orbital is called a unhybridized p orbital. Unhybridized p orbital. The remaining 3 are called a hybridized orbital, which is sp2. And the hybridized orbitals, we know that the shape is symmetrical, similarity is there, and also energy wise also same. The symmetry is this: the big lobe followed by the small lobe, another big lobe, small lobe, the third one with the small lobe. These 3 are the hybridized p orbital, hybridized sp2 orbitals of the carbon atom. And the unhybridized p orbital, the one which is not participating in hybridization, is having the normal geometry. Normal geometry of the p orbital is the dumbbell one. Same sized lobe. Both the lobes are having same size, which is having a single electron. So here I have drawn 4 orbitals in which 3 are hybridized. These 3 are hybridized. The name of the hybridization is sp2. The last one is unhybridized. Unhybridized. Okay. So as because of 2 carbon, I can say that this much is the hybridized and unhybridized orbital of the first carbon. Similarly, the second carbon is also having the same kind of hybridization because the same configuration is also there for the second carbon. So the second carbon hybridized orbitals are this: 1, 2, 3, which is sp2, and the last, the one which is not participating in hybridization, is having the normal geometry, that is unhybridized p orbital. Okay. So now I'm just putting the numbers for hybridized orbital as 1, 2 and 3. For the second carbon is, let it be 1 dash, 2 dash and 3 dash. So this is the preliminary step. Now the main step is these hybridized orbital will be overlapping. In which way it is? The hybridized orbital of the first carbon, which is 1, I'm drawing the first orbital of the first carbon, 1. Hybridized orbital number 1 of the first carbon having a single electron, which is combining with the 1 dash of the second carbon. It means this one is overlapped with the 1 dash of the second carbon. So there is another electron, so it undergoes pairing, gives sigma bond. So one merging or one orbital overlapping is done. So this is for the carbon atom. I'm talking about the carbon atom. Next, for each carbon, out of 3 hybridized orbital, 1 is being used. 2 are remaining. This is 2 and this is 3. Hybridized orbital number 2, hybridized orbital number 3. Similarly, this is 2 dash, hybridized orbital number 2 dash and hybridized orbital number 3 dash for the second carbon. Now hydrogen. There are 4 hydrogen atoms and each hydrogen atom is having s orbital in the valence shell. It combines with the hybridized orbital of these 4 in this way and gives sigma bond. This is how carbon hydrogen sigma bonds are forming. So it means all the three hybridized orbitals of each carbon are being used now. 1, 2 and 3 of first carbon, 1, 2 and 3 and 1 dash, 2 dash and 3 dash of the second carbon are being used. Now the one which is not used is the unhybridized p orbital of each carbon. This unhybridized p orbital is always lying perpendicular to the plane. So this is the unhybridized p orbital. And there is an electron, single electron is there. This unhybridized p orbital overlaps in this way. It overlaps in this way. And this is called a sidewise overlapping. Because of sidewise overlapping, a pi bond is formed. It means between carbon and carbon, one sigma bond has been already formed and now one pi bond is also formed. So pi bond is due to the axial overlapping of unhybridized p orbital. So we can draw the final geometry like this: carbon-carbon double bond and carbon-hydrogen single bond. And each carbon-hydrogen single bond is sigma, and carbon-carbon double bond in that one is sigma bond and one is pi bond. So total when we are counting carbon-carbon 1 sigma bond, carbon-hydrogen 4 sigma bonds. So total 5 sigma bonds are there and carbon-carbon 1 pi bond is also there. These are the number of bonds present in ethene. This is how the molecule is being formed. I hope you all understood. Thank you.